Hi, I'm Surya. This is my submission for Ludobot Task J. Here I'm going to show a closed loop control robot. By closed loop, what I mean is that the robot looks at its sensor values and acts accordingly. Here the sensor values acts as a feedback to the robot. Based on that feedback, changes its motor values and hence moves. So first I'll show a basic example where I have four synapses. These are the four synapses, and for starting I have kept the weight as 1. And yeah, so each of the motor is connected to uh, basically the sensor of torso and the sensor of the corresponding link. Yeah, let's try to generate this robot and then run. First we'll generate it and then run the simulate file. Yeah, as you can see, the robot keeps on moving to the right towards the user. In the first task we have to do that only. The robot will keep on moving like this. You can see the oscillatory motion, and you can see the oscillatory motion in the sensor values also. The sensor values are going minus, oscillating between -1 and 1, because the robot is jumping. For some time it is in the air, and for the remaining time it is on the ground. Yeah, let's stop the simulation. Hmm. Now for the next task, uh, what we want to do is we want to play with these weights. So let's check what if we reverse the sign of all of the weights, then what will happen. Yeah, let's try to generate a robot again and then simulate it. So you can see now the robot moves in the opposite direction. It goes away from the user and towards the left. It will keep on doing this, and the values are still oscillating between -1 and 1, but now it is going on to the opposite side because we are having the opposite effect. And you can also see the motor values, these are negative now compared to the ones earlier. These were positive. This is the reason why robot is moving on the left side and away from the origin. Yeah, let's stop this for now. Now one more thing we can try is we can try changing the magnitude of the weight and see how it affects. So we can make this as 0.5. Yeah, let's generate our robot again and then simulate. You can see that the robot's movement is quite same as earlier. There is no change in the moment because I have just changed the magnitude, not the direction, not the sign of the weights. So it will keep on moving. Let's stop this for now. So what if I give more weight to one motor and lesser to the another one? So let's keep this one 0.5 and this one is 0.5. Let's see what will happen now. Yeah, so now as you can see, this front leg robot motor is moving more compared to the back one because I have changed the weight. So this has more weight, so this is showing more change in the motor value, which is expected. Yeah, let's move on to the next task. Now in the next task we have to use more number of synapses and make the robot move towards left away from the origin. So yeah, let's go ahead and add more synapses. So I've already added this synapses. So for the starting, let's give this less weightage. Let's see how the robot behaves. As you can see, robot is going away from the origin towards right. We want it to go towards left. Now it starts going towards left and it's kind of sliding. Yeah, it's moving away from the user, but yeah, in the starting it behaved weirdly. Yeah, let's go ahead and stop this and try something, any other value. So let's just increase it and see what happens. Again it goes towards right in the starting. And now it switched direction towards left. Yeah, so it's behaving similar only. Let's go ahead and make this also 1 and see what happens. Okay, so it again went to the right, but now it came back quickly and started moving towards the left. Yeah, it is continuously moving towards left. Yeah, so this should be fine. Thank you for your time.